Hello and welcome to this week's lecture on landslides. So, what is a landslide? Well, it's a pretty loose term that refers to any mass movement of a section of the Earth, also known as mass wasting, generally by geologists. Some characteristics of landslides. The very top above where the landslide occurs is what we call the crown. There's often crown fissures, though not always. These fissures can develop before or after a landslide, if indicating further movement is yet to come. The scarp is that section where the landscape used to be and has been ripped free. It's kind of a cliff-like feature in the ground there. And then the head is the top of the material that actually slid, which could be intact if depending on the type of landslide that it was, or it might be very loose and broken up material. The shear surface, most landslides have at least one primary shear surface, which is the part of the landslide, the part of the ground that actually broke right along that surface there. In this particular diagram, down below that, along that thick line there, it's not a shear surface anymore. That's where the landslide moved onto, but what it sheared away from is the shear surface. Going around here, we have the transverse cracks. That's places where the landslide kind of bulged up over some section, and then we're getting some extensional features, kind of similar to plate tectonics, where the ground cracks open again right there. Down at the very bottom is what we call a toe, and a few places in the middle, hummocky terrain and deranged forest. That's just portions, evidences of landslide. Hummocky terrain is topography that's really has a lot of humps in it. And if you look around at the landscape sometimes, you look at a map, we'll talk about this here in a few more minutes, you'll see evidence of landslides as you see this hummocky terrain or deranged forest that has been messed up by the landslide. So there's lots of different types of landslide. They're classified by the type of material that moved and how it moved. So we can have a rock fall, or we can have a rock topple, or a rock slide, or a rock flow, etc. We can have debris, which is a mixture and a conglomerate of stuff, or earth, or dirt or mud. The movement obviously can be falling, toppling, sliding, flowing, creeping, or some complex combination of all of the above, or any of the above. So here's a couple of diagrams of some of these different types. A flow is obviously just a portion of the earth that flows in a very fluid-like manner. A topple, think of dominoes. Think of something that topples over. It doesn't go very far, but can still be devastating nonetheless. A slump is a large portion of a large block of material that slides rotationally down the hill and causes that surface to kind of slide back, as you can see the tree there. A slide, obviously material is just sliding down the mountain there. Creep, we'll talk a little bit more about creep in a minute, but it's a very slow moving but can still be very damaging type of landslide. And then a fall, obviously material is falling. Here's a couple other diagrams that I really like. They kind of show some of the environments that some of these can happen in and show a little bit different detail. We're going to talk about mud flows, and as you've already experienced from the volcanoes case studies and lessons, that a lahar is a particular type of mud flow triggered by a volcanic eruption or just increased magma movement below the surface. So these are some kind of cool diagrams there. So let's talk about some of the most common types: rock slides, earth flows, mud flows, slumps, debris flows, rock falls, creep, and cliff retreat. I almost think we should make a song about that. Let's not. Rock slides. So a rock slide is mostly intact bedrock or boulders that, well, they slide down. They can obviously cause a lot of damage. Here's one that I think occurred in Colorado. Just took out that semi-truck. I sure hope the driver was okay. So that's one of the more common ones. I don't think I need to beat the dead horse with what a rock slide actually is there. An earth flow is mostly fine-grained material. Rather than having one primary or just one shear surface, there can be many shear surfaces as the whole thing gets mixed up and churned as it moves. However, these are often slow. They don't happen super fast. It's not like one rushing. They can, but they don't always move in a very quick movement. And these often do produce that hummocky terrain that you can kind of see there. Highlight the landslide itself for you. If you haven't done the guided lab already, you'll read about a slow-moving earth flow in North Salt Lake, Utah. Mud flows, similar to earth flows, but much more watery, move very fast, and have a consistency like concrete. Lahars, again, are a volcanic example of a mud flow. Very fast, very dangerous. This is one that occurred after some intense rainfall in Los Angeles County, I believe, somewhere in Southern California. Slumps. So slumps are those ones that move in a rotational instead of what we call translational. They move rotationally. Move in discrete blocks with a single shear surface. The toe, however, often breaks up into a mud or a debris or an earth flow. This is a picture of the Oso, Washington landslide that occurred a few years ago. I think it was in 2004. In fact, one of the case studies next week is on this, and so you'll get to see this again. Notice the slump block up there at the top, and you can also see the scarp, which is a bleaking white scar on the landslide there, and some smaller blocks and then down at the bottom into the river where it broke up into earth and mud flows or debris flows. So a debris flow is more coarse-grained than a mud flow or an earth flow, non-cohesive, behaves like a liquid, although, as I'll show you in just a minute, they can be dry, completely dry. And move very fast. So I'm going to go to YouTube. We're going to watch part of a video here that shows this particular debris flow in motion. And here it is. Let's go full screen. Now watch this. You can see those boulders, huge boulders, just being pushed and tumbled down the slope there. And if you notice, there's some places where the flow kind of splashes or hits the ground and should splash if it's watery. But notice it's just dust. There's no wetness to it. Especially as it comes down the hill here, you'll see some places where there it is, right up on the side there. It's not splashing. That's not water, folks. That's just dry material flowing down the mountain. And there's probably some water, but it's not like what you think. It's not mud. It's just debris. Okay, rock falls, another common type. It's, well, when rocks fall. Depending on the slope that they fall onto, they can then continue to fall, or they can bounce, or they can roll. They can take out anything in their path. You can see this picture of the one wiping out part of this villa in Germany, right through the vineyard. There's this other car, I think it's somewhere in South America. This truck was just demolished by a boulder. Very dangerous. Don't want to be anywhere near a rock fall. Now creep, this is an interesting one. Very slow and happens seasonally. It happens through freeze-thaw cycles, which I'll show you a little diagram of in here, but can still be damaging. I'm going to go through this. That little gray trapezoid there is a block. Let's just say it's a rock sitting on the hillside. And this is a cross-section of our hill slope. Okay, so in the winter, the ground freezes and expands, and it pushes that rock out, pushes the ground out, perpendicular to the ground. But then, as it contracts again when it warms, gravity pulls it straight down. And then it happens again, gravity pulls it straight down again. And over time, you can see from the dotted line, that thing moves, and the ground literally creeps. Let's look at the close-up shot of this photograph on the side there. Notice how the fence is all deranged there and the ground is starting to creep onto the road. can still be very damaging. Imagine pipes under there. Not good. Cliff retreat is the last one we're going to talk about in detail. So basically it's cliff erosion. It can happen from water undercutting via waves or river erosion, whatever, but it can be very damaging, especially if you like to have a house up on the cliff like these folks did. This is a mansion in Lake Whitney, Texas, between Dallas and Waco. And I don't remember how long ago this happened, maybe 10 or 15 years ago. But obviously they had to condemn and abandon the home. In time, part of the mansion collapsed. A whole back porch is gone now. Then authorities burnt the place down because it was completely unsafe. And some point during that time, you can see there's the footprint of the foundation there of the original mansion. But a new crack has developed all the way through this ledge sticking out, and then eventually crack gave way. And so this is an active example of cliff retreat. Not good. So where do landslides occur? Well, they obviously occur on slopes, but they happen with weak and fractured material that's often hidden. It takes experts, geologists, engineers to determine what, and they don't always get it right, what's under the ground that could potentially create a landslide. Happens on slopes, hills, mountains that don't have to be steep, though since gravity is involved, definitely the steeper, the more prone to moving. Another place they occur, where they've already occurred. Once a landslide, always a landslide. Remember that. Here's a picture of the La Conchita, California landslide that happened in 1995. There's a case study on this. 10 years later, the same place, another landslide occurred, 2005. Once a landslide, always a landslide. So what causes landslides? Well, there's lots of natural processes, including pretty much every process that we are studying in this course: earthquakes, volcanic eruptions, intense rainfall, flooding, storm surges, and freeze-thaw cycles like we talked about, and well, simply weakened material that just gives way to gravity. Man-made processes, deforestation. Here's a picture of some hillsides in Madagascar. Now, I don't know that all of these are landslide spots, but it's definitely places of increased erosion because there are no longer big rainforest trees that are rooted into the ground holding that soil together. And so a lot of these hill slopes that once had rainforest on them in Madagascar are literally being washed away. Road cuts. If we cut the wrong hillside too steeply without supporting it, or sometimes in this case, even if we do try to support it, they can give way and cause landslides. Saturation. This happens a lot. This has happened in Utah. It's happened in the La Conchita, California slide, where overwatering, sometimes without knowing it, we put too much water on the ground for agriculture or for lawns. Even dams, which there's a case study on the Vaillant Dam in Italy, where because they built a dam, the reservoir filled up and it saturated the ground and it caused a landslide. So let's talk about some of the warning signs. Evidence of previous movement. Large boulders. I'm sure these people in southern Utah loved having these beautiful boulders in their front yard and beside their house, but I don't know that they paid attention to where those boulders came from, because unfortunately, more came down. And I think there were actually 2 killed in this disaster a few years ago. Hummocky terrain, like we talked about earlier. If you see a place with a lot of hummocky terrain, that area might still be prone to movement. This is a screenshot that I took of a map in Google Maps showing some hummocky terrain in Washington. This is in the Oso landslide area. There's lots of scarps that you can see in the map. You just have to go to the Google Maps and you can see all of these arc-shaped cliffs. And that's indication that there was formerly a landslide. New cracks can develop. Doors that don't fit in the doorway because the house is shifting. Rumbling noises. Now keep in mind, these don't all mean that there's a landslide, but they are signs. And we don't have time to go into the mitigation, so